Good afternoon. For today's video, we're going to discuss regarding basic differentiation. Our objectives here are: first, we're going to identify the following derivative formulas. We're going to illustrate or show by solving the following derivative of a function using the given formulas. So here are some of the basic derivative or differentiation formulas that we are going to use for today's video or for today's lesson. Okay. So for example number 1, so we're going to find the derivative of f of x, which is equal to 3. So your given function here is a constant, so therefore we're going to use the derivative of a constant which is equal to 0. Thus, since your given function is a constant which is 3, so the derivative is 0. So f prime of x, which is equal to 0. Okay. For our next example, so we're going to find the derivative of f of x, which is equal to 3x. So we're going to use the derivative of a constant and a variable, or the derivative of a product of the constant and a variable, which is equal to c times the derivative of v, or the derivative of a variable. So thus, f prime of x, which is equal to 3, multiplied by the derivative of x, where our derivative of x, which is equal to 1. So your f prime of x here is equal to 3 multiplied by 1, or simply your f prime of x, or the derivative of f of x, which is equal to 3. Okay. We have here another example. So we're going to find the derivative of f of x, which is equal to the quantity x multiplied by 3 multiplied by the quantity x minus 1. So we're going to use two methods here. So first, we're going to use the product of differentiation, or the product rule of the differentiation, which is the derivative of u times v, which is equal to v du plus u dv. So thus, we're going to let u, which is equal to x plus 3, and v, which is equal to x minus 1. So if we're going to get the derivative of each function, where since it will only be equal to 1. So if we're going to get the derivative of each constant, that will be equal to 0. Okay. So let's apply the rule. This will be 1 multiplied by x minus 1 plus 1 multiplied by x minus 3. So this will be the same, because you're going to multiply the function by 1, so it will be the same. So this will be also like x minus 1 plus x plus 3. So we're going to combine similar terms, combine the two variables, the two x's and the two constants. So your answer will be the f prime of x, or the derivative of the function, which is 2x plus 2. So this is method 1. So if we're going to use another method, which is we can use the FOIL method in determining the derivative of the function. So we're going to back to algebra. So the FOIL, again, if we're going to recall, F means first term, O, which means outer term, I, which is equal to the inner term, and L, which is equal to the last term. So after we get the product of the two functions, then we're going to differentiate, or we're going to find the derivative. So it will become like this if we're going to use the FOIL method. So this will become x squared plus 2x minus 3. Okay, so if we're going to solve it further, so for each term we're going to need we need to use separate formulas for each term. Okay, so for the first term, or for x squared, we're going to use the power formula for differentiation, or the derivative of u raised to n, which is equal to n multiplied by u raised to n minus 1 times the derivative of u. So if we're going to get the derivative of x squared, that will become 2x. So for 2x, for the second term, we're going to use the derivative of the constant and the variable. So c times the derivative of the variable x. So making 2x, or making the derivative of 2x, which is equal to 2. And for the last term, or for the third term, since it is a constant, we're going to use the derivative of a constant, which is equal to 0. Thus, so if we're going to include the sign, so regardless of if it is positive or negative, the derivative of a constant is 0. So thus, the derivative of your function here, which is equal to 2x plus 2. Okay, so for your activity, you're going to find the derivative of the following functions. So if you need more time, you need to pause this video. Okay, let's check. The answers should be, for number 1, that should be equal to 3x squared minus 6x plus 3. For number 2, f prime of x, which is equal to x plus 1 over the square root of x squared plus 2x. And for number 3, the answer should be 4 over quantity x plus 1 squared. So did you get a perfect score for this activity? Okay, let's so if so, okay, then good. Okay, if not, then practice more. So let's check the solutions. Okay, so for number 1, so f of x, which is equal to x quantity x minus 1 raised to the third power. So if you're not sure of what are going to do, just expand x minus 1 3 times and then multiply it using the FOIL method. Okay, so, or if you're going to use the Pascal's triangle, so you need to remember the constants. So the expanded form of quantity x minus 1 raised to the third power, which is equal to x cubed minus 3x squared plus 3x minus 1. That's for the first item. Okay, so then get the derivative, or differentiate, which is equal to 3x squared minus 6x plus 3. Okay, or if you are into factoring, you can factor it also. You may do so. That will be also the same. Okay, so for number 2, we have f of x, which is equal to x squared, or the square root of x squared plus 2x. So to make it simpler, we're going to use the derivative of square root of u, which is equal to the derivative of u over 2 square root of u. Although that is derived also from the power formula for differentiation. Okay, so if we're going to let u inside the square root or inside the radical sign, which is x squared plus 2x, so if we're going to get its derivative, which should be, or which is 2x plus 2. So the f prime of the function, or f prime of x, which is equal to 2x plus 2 over 2 multiplied by this 2 over 2 square root of x squared plus 2x. So we need to simplify it further. So for the numerator above, we have to factor 2. This should be 2 multiplied by x plus 1 over 2 square root of x squared plus 2x, and therefore 2 is cancelled out. So your answer must be, or the derivative of the second item, which should be x plus 1 over square root of x squared plus 2x. And lastly, for number 3, for f of x, which is equal to x minus 3 over x plus 1, so just going to let let x minus 3 as u, and derivative of u, which is equal to 1. So let v be your denominator, which is equal to x plus 1, and the derivative of v, of course, which is equal to 1. Okay, using the quotient rule, so the derivative of u over v, which is equal to v du minus u dv over v squared. Okay, so let's apply v du 1 multiplied by x plus 1 minus 1 multiplied by x minus 3. Okay, so that's just to show how the process is done. Okay, so that will be x plus 1 minus x plus 3 over quantity x plus 1 squared. So your answer must be 4 over x plus quantity x plus 1 squared. Okay, so for your assignment here, you're just going to find the derivative of the following functions. You can email your assignment using the Microsoft Word, or just attach it here, or just comment down below. Okay, so if you have no more questions, okay, I will see you in the next video.